Welcome back, everyone. We are starting the next chapter, which is chapter 2, and we are talking about our first C++ programs. So, we are going to learn some syntaxes, some hands on programming example regarding how do you define a C++ program, what are the syntaxes you need to take care of, kind of some of the directives, how to put the comments, all those things. So a typical C++ program looks like this one, the one you see on the slides. Here you can see that the program starts with a directive called include, and you are including IO stream, which is a module that contains the resources for inputting and outputting some streams. Like if you want to create a comment, create some texts onto your console, if you write to print something on your console, or if you want to read something from your keyboard, you typically include this particular module. So this is a preprocessor directive. When you do the include, it is a preprocessor directive. It's not a statement. So why do you use these includes? The IO stream has some code inside it, right? I mean, it's a module. It can contain classes. Class means, class is nothing but some form of object-oriented programming where the objects are blueprinted inside the class. We are not talking about classes yet, but that's something you should already be knowing. Or I mean, you will be knowing. Sorry, not already be knowing. You are just starting C++, so you will be knowing all this stuff. But these statements. You start with this preprocessor directive. Then you write using namespace std. So, what does it mean when you write using namespace std? That's a very good question, in C++. So, using namespace std that I write in this line, this one, it simply means that we can use names for objects and variables from the standard library. If you don't understand how include IOStream and using namespace std work, just think of it as something that almost always appear in your program. I mean that you can think in that way, but to the namespaces, the namespaces are directives. So a namespace is a declarative region that provides a scope to the identifiers inside it. The namespaces are used to organize code into logical groups and to prevent name collisions that can occur, especially when your code base includes multiple libraries. You can take a look at namespaces discussion from the Microsoft knowledge area regarding C++. You have very good explanation of the namespace here. So you can learn it from Microsoft knowledge base. Okay. Now, as we go to the program, move on to the program, you first see int main. So what is the main program? So the main function, this is a function, first of all, and it has a data type, a return type that is integer. Integer is the data type for the whatever you return from the main function. The main function serves as the starting point for the program execution. It generally controls program execution by directing the calls to other functions in the program. Okay? So you go to main program, you declare it, you start with a curly brace so that you can specify the region under which the main function has some code, some statements. So the first statement is cout. Cout stays inside the IO stream module. So what it does, basically it creates these state like these texts like welcome to the calorie calculator to the console. Now comes the comment get number of servings from user. So when you use the comment, you use this double slash symbol in C++. This simply means that your compiler is going to ignore this line when you put double slash. You can place the double slash next to a comment, next to a directive like this one, or you can put it here as a comment. So what will happen here after the semicolon? Semicolon designates the end of the statement for C++, and after that you put a double slash. That means you are writing a comment, and then you write whatever you want there. Comments are often used to create some kind of documentation inside the code. So now we define double serving. So double is the data type. Treat it as a decimal data type. And servings is an identifier or a variable. So what it does, basically next line we write the cout. So your screen will show enter servings per food item. Then you write cin. Cin is a way you can extract the texts from the keyboard. When you type on your console, it extracts that typed characters. And then those characters are set. I mean, those are placed onto the against the, I mean, those are assigned to the servings data variable or identifier. Then you write another comment. Then you write another double variable or double identifier called calories. Now you write some cout statement, that is, this will show up on your screen. And then that is followed by the cin, which is basically you are reading from your screen. So you are reading the calories from the screen. Then you calculate the total calories, or you write double total calories servings times calories, and then you cout total calories equals total calories. I mean, that's a variable you created. I mean, that's the identifier where you store the calculated value of servings times calories, and then you write the end L. End L is the end line. This is a part of your IO stream package. So it designates end of the line. So here how many lines, end lines you will see? There are two of them, right? And then finally you write return zero. That means zero means everything returns gracefully. It's a normal exit. And that's all constitutes your first C++ code. As an hands-on example, let's create a new project on our Visual Studio. So project, and then we choose the console app. I already explained about it during the last lecture. And then we can do the next here. So now we can tell the the name, I mean the console app application to the name of the project, you can say um, calorie. That's just calorie. That's okay. I mean, it doesn't matter what you write. It's calorie, and then you create it. So you are creating a project named calories. Okay. So this is a template source code that you receive that you get out of Visual Studio. So that's a great benefit. You get something, um, some template. So let's now put together the calorie code. So first you include the directive, include IO stream, right? Then you write using namespace std. So you define the namespace, then you start writing the main program and you put the return 0. That is your shell of the first program. Now let's write the statements. First, we write a statement cout and we can say welcome to calorie calculator. So it can be something like this. Then we get the number of servings from the user. So that can be done in this way. So next step is get the number of calories from the user. Okay, you got it there, right? Now you calculate the total calories. So that is calories and number of servings. So you are creating a diet application basically here. So finally you display the total calories. Okay, so that's how you do it. So that's your code. You see, I mean, whatever we explained in our slide, we wrote it here. It's very simple. You put, now you will see one to one, like line to line, how it is converted into the console interaction. So we have to start the program by clicking on local Windows debugger, this green arrow. So let's do that. As we start, you will see this console appears. So this is your cout. First, welcome to the calorie calculator. It's here. Then you write double servings. It's an identifier, and then you cout enter servings for food item. That's what it is written. There is no line gap after that. So the cin appears next to that. So let's put some number. Let's say 9. Then you have next statement, next comment, and not the comment, next statement that will create some output to your console, that is enter calories per serving. So that's what it is coming here, line number 15. Then line number 16, we enter the calories. Let's say we put 100 calories. So the total calories becomes 900. So that's what we wanted to calculate, right? The total calories. And there are two end lines, so that's why there are two gaps. Okay, so that's how your line by line code is converted into an output like this. When you do your programming with Visual Studio, you should do it in this way. You first create a project, right, and that will give you a um, placeholder main.cpp, and then you move forward with the remaining steps. Okay. Okay, so let's move forward. The comments we have used so far are single line comments, but you can also use block comments. Typically, the block comments look like this. Let's go to the calorie calculator again. Uh, Let me open the program again. So here it is that we wrote. So the blocks comment, this is a single line comment, And block comment may be like this. You put a slash and then you put a star. This is matched, that this is ended by matching star slash. Now in between these two, star slash star and star slash, you put your comments. Let's say you write author. I'm putting my name as I wrote the program. Date. Let's put today's date. And let's put description, calorie calculation code. You can have more substantial description, of course, but when you use the block comment, you are sending a message to your compiler to exclude, to ignore whatever is written in between these two symbols. Okay, this is called block comment. The main function can have no parameters. That's what we did. It can have also two parameters, argc and argv. The main function cannot have any other variation than variation number one or variation number two. I mean, as far as the arguments go. So what are these means? So in order to understand their significance, let's do something different. Let's say let's create some another function, another project, just to illustrate the main function, main illustration. So create. So you have this one. Now let's put using namespace std. So now you can put int argc char star star. Now just assume that this is a symbol star star. These later on you will find that these are pointers. These are used to designate some pointers that deals with some memory, dynamic memory. Argv, an array. So what does it mean after all? So argc is how many arguments you are passing when you run the program. So let's see out this one, see out argc. So let's say uh, argc, this is the text, it will appear, and then the value, and write end line. And then for unfolding argv, you know, this is an array. In order to unfold the elements of the array, typically we run a for loop. We'll discuss the loops later, but right now just assume that for is a loop that will loop over all the values contained in argv. So let's write the for loop structure like this one. You will learn it later. I'm just typing it just to illustrate the significance of argc and argv. So we write argc, this is an integer, and then I plus plus. So you are looping, and then finally you can put cout argv, and then you can put the value of I as well, and then you put an equal sign so that you have a very well formed text, and then you write argv I end line. So once you do that, let's go to the properties in order to define the command line arguments, properties, and then we go to debugging. Okay, so then go to configuration manager, not this one, sorry, debugging properties. So you write the command line arguments. Let's write some arguments here. As you do edit, then the screen pops up. Let's say you are passing on three arguments, three, let's say 1, 5, and 9. These are the three arguments you are passing. So your ARGC is 3. In this case, your ARGV is 159. That is ARGV 0, I mean 0th index. The first index is, 0th index is 1. Second index is 5. Third index is 9. And if you configure it like this and apply, and then you run the program, you will see some console like that. Now, there is some difference. You are putting 3 as ARGC, but ARGC is essentially 5. So what does it mean? What is going on here? Let's see. Um, let's try to define them again. Uh, Properties, command line arguments. So if I put 5, so ARGC is basically 5. So let's do the character passing. So 3, let's say we write ABC, CD, F, I, J, K. Okay, and then apply. Okay, and then let's run it. It looks a little weird. So let's try it again. So what we can do here is there should be character star ARGV, and then we have the ARGC. Let's say we put together three arguments, but essentially there will be 5 because you have the executable file name, and then you have the ARGC, and then you have the ARGV. Three values are there for ARGV. So you write it like that. Okay. And then you run the program. You will see the screen. So you see here, there are 5 values for the ARGC. So 0th value is 0. You have this program, and then you have ARGV1 is the 5. Then you have all the individual values for those arrays. So that's how you pass the values. Okay. You could do it in the other way as well. Like you can do it like you put together this one to be equals 3. Doesn't matter. I mean, 3, you are defining 3 variables. So you do it like that. Okay. Apply. Okay. So now if you run the program, your ARGC will still be 5 when you do the ARC out, but then the ARGV values, there are 4 values considered here. Let's do it again. So let's say you are defining just three values: ABCD, ABC, CDF, and IJK. So here's how you can do it. You can put it like just this: ABC, CDF, and IJK. Okay, so these are the 3 values you are passing as a part of the program. Then you write OK, and then you execute the program. Then you will see that ARGC, total number of ARGC is 4. For ARGB, the first one is the executable program, and next ones are the values that you are passing to the program. Okay, so the first value of ARGB is always reserved to be your actual value that you are passing to the program, but the remaining ones are the ones that you are passing. The first one is the executable file. The remaining ones are the files that user is passing to the program. Okay, that's how you execute the second category of main function. The return type can be exit underscore success. There can be multiple standard return values like this one. 0 is normal exit for all C++ version, but for version 11 or later, you can use exit success for normal exit, exit failure for abnormal exit. but these keywords are available only after C++ 11 version. Now comes the identifier. You know what is identifier? Identifier is nothing but a variable. So in this case, let's say not this program, let's say this program. Let me open the existing one that we just wrote, calorie program. So if we go to the calorie, so here, which one is the identifier? Servings is an identifier. Anything else? Calories is an identifier. Total calories is another identifier. So identifier means the variables that you use in the program, define in the program. So the valid identifiers are something like this: subtotal. You can have I. You can see it can start with an underscore symbol. It can have some numbers after you have the character to start with. You can have it can has underscore in between. So the rules for the naming an identifier, that is, you should start each identifier with an upper or lowercase letter or underscore. Then you should use letters, underscores, or digits for subsequent characters. You cannot start an identifier with a digit. You should not use the keywords used in C++ or C. What are those? Some examples, like you see here, bool is a data type. So you cannot use it as an identifier name. You cannot just say double bool, because bool is already reserved in C++. There are a lot of other examples, and some examples are here too. Some C examples are here. So you cannot use these values, these texts as your valid identifiers. Okay? So if you want to use double, can you do like this? Double, that's the data type, and then you write double. So what is going to happen? The program will throw some error because this one is not a valid identifier. Okay? There are two built-in data types for working with numbers in C++. One is integer, another is double. Double is some sort of decimal. Integer is, integer. So how do you define and initialize a variable in two statements? So you define the variable in this way, int counter. So that means you are defining an identifier counter and its data type is int or integer. Then you initialize the value as counter equals 1. Okay? You can do it in a single line as well. You can write int counter equals 1, double unit price equals 14.95. Not all languages allow this feature, but C++ does allow this feature. This is a flexibility, one of the flexibilities in the C++. The assignment statement, what is assignment? In this case, 0 is a value which is assigned to the variable quantity or to the identifier quantity. 100 is the value which is assigned to max quantity. So you can have two assignment statements as follows: quantity equals 10, but then quantity equals max quantity, because max quantity is already initialized, and you can assign quantity to be the max quantity. So for assignment, you don't have to use some predefined fixed number. You can use some dynamic variable as well there, because then quantity will be assigned to the variable whatever value max quantity has. Okay? In every language, whenever you write a code, you create a project, you solve some business problem, there is always a best practice recommendation. So in C++, the recommended naming convention for the variables are as follows. Like, you have each variable name that should be a noun or a noun preceded by one or more adjectives. You can try to use more meaningful names compatible with your project requirement. Let's say you have a project where you are calculating the discount, and discount is a double, right? I mean, it's a decimal number. So you can write double discount, or you can more specifically you could write discount price, something like that. You should not write double xyz equals whatever the discount value. I mean, it is not incorrect. Compiler will compile it, no problem with the program, but the program becomes ununderstandable. In order to make your program more readable, more maintainable, you should use these recommendations. You should you should try to use meaningful names, and you should use lowercase letters and separate the words with underscore in this way. There are arithmetic operators, mathematical operators, but there can be multiple mathematical operators, but arithmetic operators, there are five of them, like addition, plus sign, subtraction, minus sign, multiplication. It's usually in mathematics you have seen it's a cross sign, but in programming world it is a star symbol. Then you have a division sign, which is the slash. Now the modulus. What is modulus? Does anybody know what modulus is? So it's a, you know, let's say 5 divided by 2. What's the value? There is a result of 2. 2 times 2 is 4, and the remainder is 1, right? So your modulus of 5 modulus 2 is 1. So it's a reminder if you divide the first argument with the second argument. So if you have 10 modulus 2, what should be its value? Should be 0, right? Now you can have statements with simple arithmetic operations, expressions like this for integers. These are the things. You have x equals 14, y equals 8. You have result x plus y. Um, you can also see the decimal arithmetic, like you are just adding them up as far as the decimal laws. The increment, how do you increment a value? So you have initialized it to be 0, the counter. Then you have counter equals counter plus 1. At this line, what is the value of the counter? It's 1, right? 0 plus 1. But at this line, second line, the value will be this value, this counter value is already 1. So 1 plus 1 equals 2. So you have counter equals 2. That's how you increment the variables. You can mix integer and double variables. That's a little bit tricky. Practice it out. So you have a double variable 251. Now you have integer counter. If you divide 251 by counter 0, non, I'm sorry, let's say that is 2, then what should be the value? If it is double, if you designate it to be double, then it should be literally 125.5. But if you designate the result to be an integer, then it will not take into account this decimal counterpart. It will be simply 125, nearest integer. A statement that divides an integer by integer, however, it's pretty simple. It should be resulted by 0, I mean point 0. The value that results out of this division is a double, so that's why it shows the decimal point. There are common header files of the C++ library, standard library. Those are like cstdleave, iostream. We already talked about iostream. There are multiple others. cmath is a mathematical library. String, vector, we'll see. For a complete reference, you can take a look at this header file, list of the header files. So the typical way or the syntax to include a header file is like the one I show here. You should not include a header file inside the code. If you do so, then there will be compiler error. Okay, you should start your code by including the header files. Now, two variables from IOStream header we have already seen. Cout that outputs the statements, outputs the texts onto your screen, and endl is basically end of line. If you send a message to the console, you can do it like this: cout and then use this symbol hello. So then you see this on the console. Now you can send a text and number to the console as well. You can do cout 4 times 4 is, and then the result here 16, right? And it becomes 16. There is no end of line here. That's why you see continuous. Although these are the two different statements, but you see the continuous one line in the output because you did not put any end line, endl. There is another way you can just join them together. You can see cout just used once. Then you write this symbol and then you write 4 times 4 like this one. And then you don't write another cout. You can just write this appender and then say result. So the outputs are identical, however. You can send multiple lines to console like this example. You have this is line 1, then you end the line. So next line comes, this is line 2, again end the line, third line comes, this is line 3. But there is another way. You can write, you don't have to end the statement with a semicolon and start over with cout. You can write cout once and then you include the end line multiple times. Like here, you have line 1, end line, line 2, end line, and line 3. So the result will be the same. Another object variable from IOStream header is cin. We talked about it, right? You read one value from the console using cin. Here is how you can do that. So you have defined the identifier, then you write the cout just to tell user what to do. So user sees that you want them to enter a number, then the user writes a number, whatever value is. So they they see this line first, they enter this number, and they see the output coming as this one because you do some calculation and then you are outputting the results. Okay, you can read multiple values from the console. So this is simple. You can use two cin statements like this one, or you can use a single cin statement like uh, here. So you don't have to, here you could read it as cin value 1, cin value 2 using two statements, but you can use it you can do it as a single statement as well. But there is some issue with these CIN directives. We are going to discuss that. So some code examples. What I suggest you is that feel free to copy and paste this code into your one of the newly created project onto the Visual Studio window and practice this code. That will give you some learning experience. We will talk about the CIN issues later, but there are 5 CMath functions, mathematical functions. You can talk about the square root. You know, this is just like this. Remember this one, square root 16 equals 4, right? You have the power. Power means, let's say you write x to the power 5. Typically, this one you write here as base is x, power is 5. So you write POW 5, sorry, x 5. That's how you do it. There is a round function, there is a float, there is ceiling. We are going to illustrate it later. Now, the syntax to call a function is you write the function name. So if you call the square root function, this is a function. So you write sqrt here, and then you pass the argument. only one argument is expected, so you can write, let's say 25. So that will give you 5, right? Anyways, you don't need to write 5, but this is your syntax for calling the square root function. So examples are here: square root function, then the power function, POW function, then you have the round function. So it's round to the next nearest digit. See the tricks for rounding to 1 decimal, 2 decimal, and so on. The floor function is also like that. Try to understand how the floor is defined. And similarly, the ceiling function. You know, ceiling is the next possible value, integer. I mean, next possible value, in fact. But you know, the the floor is the previous value. You can. We already talked about the std namespace. I'm skipping this one. So um, there are two functions for the cstd leave header. Those are used for generating random numbers. Those are rand and strand. You know, strand is for giving this random number generator some seeds. Okay, there is one function of the ctime header, that is time. So if you use the random number, let's say, let's roll some dices, and you will see the dice roll program here. Note that we put the null pointer. That means it's nothing. Null is nothing, right? Null is not zero. Null is nothing. So time has an object that is inputted, that is passed as an argument. Now we put it as the timer. Actually, there is no timer involved here. So you use the default timer of the computer. So then you write the strand as your the time in seconds, current time in seconds. That is your seed. The beauty of this is that this changes constantly with the time. So strand is never the same. So you roll the dice. As time passes, it picks up different seeds and it produces different results. So you can try this code on your Visual Studio and see how it works when you roll the dice. What are the different numbers that comes up? The built-in data type for characters is the char, char, char. You can define like this one. You know, char is a single character, and this is enclosed by, wrapped by um, single quote. So let's say you write char my char. Let's say this is some arbitrary character, and you can say a. Okay, but there is a different text data type that is called string. It's an object. It's defined by a class. Class is a blueprint of an object in C++. So string is defined in a class, and you can include string in this way. So when you include this, you can start using the string data type, and you see this is a fully functional text. So this is called string. I mean, the difference between character and string is that char contains just one uh, character, a. This is char, but the string is uh, a, b, c, d, e, f. This is a total string. But you can use a enclosed by double quotes as a string as well. This is a string, but this one is a char. Okay, you can concatenate strings and chars. It's very simple because you can just put the plus sign and note how we manipulate the output. Try it on your screen, practice it, and that way you will understand. So what it does, it prints the last name, so that's the Bob. So it's the variable, right? Or identifier. So you write last name, which is Bob, plus, and then you explicitly pass a string like comma and space. Space is also a string. And then you write the first name, which is, well, the last name is Smith and first name is Bob. So um, your output can be Smith, comma, Bob. And after comma, there is a space. Okay. So you can do it in this way as well. Name, first name, middle initial, last name. If your middle initial is M, then your name is Bob M. Smith. You can append one string to another using the plus equals operator. The plus equals means, um, you know, you are so then the value of name in this line is nothing, right? I mean, it's a blank string, empty string. Now it becomes first name, which is Bob, and then space. The value of name in the second step, it starts with Bob space and then you append plus equals, you add last name to it and it becomes Bob space Smith. There is an escape sequences for the special characters. So you can use slash backslash n, that stands for new line, backslash t, that stands for tab, backslash r, return, backslash double quote, quotation mark, backslash, and then backslash again, that is your backslash. These are the symbols you need to escape these characters in order to get the meaningful symbols. So let's say you do that. So what it does, basically it writes a code cpp and then give a new line, create a new line, and then writes price equals 49.50. So this is the result. You have different examples as well. Tab delimited, so Joe tab Smith, so you have a tab, so that's why you have this space here. And then you have a new line, you write Kate, and then you again puts a tab, then you write the final string, that is Lewis. So the strings can use the double quotes as well, but for using double quotes, you have to escape that. So you cannot just write type double quote X double quote. You cannot just write, because then that will be, if you write type starts with double quote X, that means um, it is confusing, because as if the double quote ends here and then you will get an error, syntax error. But you could do it in a different way, like you can escape and then you can get these double quotes here. Other examples are here as well. The character example, I mean, the new line is this one, tab is this, separator is this one. Now comes important thing, that cin. You remember that we did cin variable 1, variable 2. Get line is another solution to read uh, a line by line. So get line basically reads a line. So how it works? You define the name, it's an identifier, then you enter the full name, then you get the get line. I mean, whatever you put together on the single line, you read it using the get line. So you enter the full name as Grace M. Hopper, and then you are reading the entire Grace M. Hopper, and you create it, and you see that name is set as Grace M. Hopper. So you are reading the entire line. You don't go by uh, string to string. There are member functions of the scene objects like get, ignore, and ignore with some parameters. So it's like that. Um, you have the extract and return the next character. You do scene get. Extract and discard the next character is ignore, and extract and discard the next 100 characters here, or all characters up to the next base. So if it is less than 100 characters, then uh, it will be the next character. code that pauses until the user presses enter. This is very important because we use it frequently. So typically what you do, you write C ignore and then um, it discards any extra characters on the current line. Now you write press enter and then you write C in ignore this way. That way it will be paused and then once you create the enter, then you know then you see uh, the, the the program goes to the next step. There are common problems reading the string. So here, using the cin, it extracts the data but leaves the new line character, you know. But here, it extracts the data, it reads the new line character left in the stream as well. Okay. So we have, you can do the reading string issue. I mean, like you can do ignore, it discards the new line character and then it reads the next line like this one. Skipping these lines, there are a lot of examples. So what is the error here? You see here, the error is after cout, you don't have any semicolon. So your compiler does not even know that you have ended a statement. It immediately goes to string and then it does not find anything like I mean cout whatever it is and then comes string. So it's an error. So that's what it says. In order to debug the program for the runtime error, you should go to the line in the source code that was running when the program crashed. For the logical error, you should figure out how the source code produced that output. You can put a lot of debug statements in between the code, lot of couts to find out exactly where the error is happening. Then you can fix the code and test the program again. So that's pretty much our lesson from writing your first code in C++. Let me know if you have any questions. Talk to you soon. Bye.